Hi guys, welcome to my channel Learning with Sarita. In this session, we will discuss the topic electric field due to a system of point charges. Guys, what do you mean by system of point charges? Many number of charges or multiple charge system or n number of charges, isn't it? Now, you consider a multiple charge system. Let Q1, Q2, Q3 and so on up to Qn be the charges in the multiple charge system. Now we consider a point P. What we have to find is the electric field at the point P. By using the concept of superposition principle, the electric field at the point P can be found. As the first part of this session, let me tell you the concept of superposition of electric field. Here we consider a multiple charge system and take a arbitrary point in the multiple charge system. What is an arbitrary point? Any particular point in a random system is an arbitrary point. Let the point be P. Okay. Now, the electric field at an arbitrary point due to a collection of point charges is simply equal to the vector sum of the electric fields created by the individual point charges. The system is a multiple charge system and we are considering an arbitrary point P. Then to find the electric field at the point P, the concept behind is the electric field at an arbitrary point due to a collection of point charges is simply equal to the vector sum of the electric fields created by the individual point charges. And this concept is the superposition of electric fields. As second part of this topic, we are going to draw diagram for superposition of electric field. Let Q1, Q2, Q3 be the three charges. Here Q1, Q2, Q3 are at a distance of R1P, R2P, R3P from the point P. We know that R1P is the distance between Q1 and P and R2P is distance between Q2 and P and R3P is distance between Q3 and P and R1P unit is unit vector pointing from Q1 towards P and R2P unit is unit vector pointing from Q2 towards P and R3P unit is unit vector pointing from Q3 towards P. Okay, now the charges Q1, Q2, Q3 will be creating the electric field E1 vector, E2 vector, E3 vector, isn't it? And we all know the concept that the electric field E vector and the distance R are inversely proportional. E vector is inversely proportional to square of the distance. That is, the length of the electric field vector depends on the distance. This is given by relative length of the electric field vector for the charges depend on relative distance of the charges to the point P. Okay students, the relative length of the electric field vector for the charges depend on relative distance of the charges to the point P. By keeping this concept in mind, we are going to draw E1P vector, E2P vector and E3P vector for the charges. Okay, first we will draw E1P vector for charge Q1. Here we take the multiple charge system with point P. First we consider the charge Q1. You see here the charge Q1 is somewhat closer to the point P, that is R1P distance is lesser. For lesser distance of R1P, the length of the electric field vector E1P is longer. You have to draw a long line. And now we are going to draw E2P vector for charge Q2. Here you see that the distance R2P is of longer distance from the point P. The charge Q2 is somewhat longer from the point P. Then R2P is increased means what happens to E2P vector? The length will be shorter. For shorter length of E2P vector, R2P increases, so E2P decreases. Now we draw E3P vector for charge Q3. Here you see the charge Q3 is at a distance somewhat lesser than R2P, so that the electric field length vector E3P vector will be a somewhat in between distance you have to draw. Here you see R3P decreases, so again the length of E3P is increasing here. Now for this picture we have to draw E total vector. Here there is a point P and there are three vectors, E1P, E2P and E3P vector. We have to add all these three vectors. We are going to use vector addition to add the n number of vectors. We have to form a vector chain. So what we have to do? For E2P vector and E3P vector, we have to draw parallel vectors. Here you see, for E2P vector, we draw a parallel vector. Where the E1P ends, you have to draw E2P parallel vector. And then we have to draw E3P vector. See, here we have E3P vector and just the parallel line we have drawn here. Okay. Now we have to find the total for E1P, E2P and E3P. For this, from the origin P, we have to draw a line to E3P vector, end of line, end of vector E3P vector. What we get? E resultant vector. E resultant is nothing but E total, that is equal to E1P vector plus E2P vector plus E3P vector. Nothing but the vector sum of the electric fields. Now as the third part of this session, we are going to find an expression for E total vector. Let Q1, Q2, Q3 and so on up to Qn be the collection of charges located at various points in space. And now the electric field at the point P due to n number of charges will be E1 vector plus E2 vector plus E3 vector plus and so on up to En vector. Now E total vector is equal to E1P vector plus E2P vector plus E3P vector plus and so on up to ENP vector. We know that E vector is equal to 1 by 4 pi epsilon naught Q by R square R unit. Now what will be E total vector? 1 by 4 pi epsilon naught is commonly taken and we get Q1 by R1P square R1P unit plus Q2 by R2P square R2P unit plus Q3 by R3P square R3P unit plus and so on up to Qn by Rnp square Rnp unit and close bracket. Okay. Now we know that R1P, R2P, R3P and so on up to Rnp are the distance of Q1, Q2, Q3 and so on up to Qn from point P respectively. And R1P unit, R2P unit, R3P unit and so on up to Rnp unit are the unit vectors pointing from Q1, Q2, Q3 and so on up to Qn towards P. Now since we are writing plus symbol throughout the expression, we can remove and put summation symbol. E total vector is equal to 1 by 4 pi epsilon naught summation I is equal to 1 to n qi by r ip square r ip unit within brackets. And students, this expression is used to find the electric field due to the system of point charges. So far we have discussed this topic in 3 parts. In first part, we learned the concept of superposition of electric field. In second part, we learned how to draw the diagram. And in third part, we derived an expression for E total vector. Okay guys, after listening to this topic, you take your note and recollect the points. It will be very helpful in your studies. Thank you.